In this video, we're going to talk a little bit about some geometry things. I'm going to show you some shortcuts. They're called angle theorems. Now, some of these you're going to know very quickly, and others it's been a while. So let's talk about something simple. If you had a triangle, and let's say the angles are x, 2x, and 3x, just so that they're not all the same. By definition, all of these angles equal 180 degrees. So in this case, you could say that angle x plus 2x plus 3x equals 180. So if you add those together, 3, 4, 5, 6x equals 180. So x equals 30. So if this one is 30, then 2x is 60, and then that one would be a 90. Obviously not drawn to scale at all, but you can figure those out knowing that all the angles of a triangle equal 180 degrees. Now, you probably already know that one. Here's another one that you may not know. Let's say that I had a triangle like this, and I had angle 1, 2, 3, but I want to know that angle. Okay? Well, there's a little bit of shortcut, and the shortcut on this says that angle x, the measure of angle x, is going to be equal to the measure of angle 1 plus the measure of angle 2. So you don't have, now you know that the degrees on a line, if that's a straight line, that's 180 degrees. It would be real simple if I knew angle 3, 180 minus 3 gives me that answer. But if you don't have that number, but you have these, even if it's symbols, so let's say this was 2x and this was 1x, then I know that this x out here is going to be equal to the 2x plus the 1x if I don't have real numbers. And make that a little more visible. And so I know that that's going to be true. And the reason that's going to be true is, since this rule says that all the angles equal 180, since 1 plus 2 plus 3, angles 1, 2, and 3 equal 180, and then a line, so also angle 3 plus x equals 180. If you put those two formulas together, since they both are 180, it actually helps you to know that this outside exterior angle is equal to these two added together. Now, you may not have known that one, but there's another one for you. Here's another example of just some angle theorems that are shortcuts for you to figure out. Let's say that we had, I'm not the best geometry, that's not a very good polygon, but anyway, let's say that we wanted to know polygons, and we want to know specifically their interior angles. All right, well, there's a formula that says n minus 2 times 180 equals the degrees of your interior angles, n being the n equals number of sides of the polygon. 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 is 4 times 180 equals the answer here, which in this case is 720 degrees. But if you want to do it a little faster, what you can do, here's an alternate way in case you didn't know that one. If you pick one of the vertex and then draw however many triangles, notice that's a triangle, and that's a triangle. How many triangles did you make inside there? So again, starting at one vertex, 1, 2, 3, that's the only lines I can make. I made 4 triangles. Each triangle has 180 degrees. 4 times 180, you'll notice I got the same math. So it works either way. Okay, so if you didn't remember, what's this formula, something minus 2? Go from one vertex, draw all the triangles, go to all the other vertex, or the vertices that you can see across from it, so you can't draw that one one's already drawn. So you have 1, 2, 3, 4, and I know triangles are 180 degrees, you'll end up getting the same answer. So that one's a pretty cool one, knowing that a triangle is 180. All right, here's another one. Let's say this time we want to know a polygon, but we want to know its exterior angles outside. So let's say that we took a triangle, and let's say this was 60 degrees, 60 degrees, and 60. There's your 180. If they want to know some exterior angles, like they want to know that one, and they want to know that one, and they want to know that one. They want to know those degrees. Well, the rule on this is the sum is equal to 360 degrees. So whatever, however many of those there are, the sum of those always equal 360. So x and x and x. Well, if you do math looking here, if this is a straight line, I bet this is 120, because 120 and 60 is 180. That means that one's also 120. That one's also 120. 120 3 times is 360. Now, it doesn't have to just be on a triangle, okay? So you can actually do the math to figure it out without having to draw it. Let me show you what I mean. Let's say we have a decagon. Deca means 10, so it has 10 sides. And I want to know the interior and exterior angles. The very first thing I can do is I can go back to that other equation that says n minus 2 times 180. So if that has 10 sides, minus 2, that's 8. 8 times 180. All I have to do is take my handy-dandy calculator. 8 times 180 equals, that's how many all the degrees of the interior angles have to add up to. But how many angles are inside that? There's 10 angles. So each angle, if they all add up to 1440, divided by 10 is 144. So each angle is 144 degrees inside. That's your interior angles. If you want your exterior angles, we already said that has to equal 360. Okay? So you have 10 sides. Well, how much is each side? Divide by 10. Each side, at each of those corners, they're going to be 36 degrees. And so I can get each of those by dividing. Okay, so I got the interior and exterior. I didn't have to draw a 10-sided figure. I could use what I knew and get that information very quickly. The last theorem that I want to show you is probably one of the most prevalent. It's the one you probably spend a lot of time in geometry on. Let's say you have two parallel lines cut by another line. Okay? So basically it looks like streets. You have two streets that are parallel, and you have something that crosses them. And they give you these angles. And they want to know, what are all of these angles? Well, there's some patterns that'll make your life a lot easier. Okay? And here they are. And I'm going to number them. I'll make this a little shorter. And they use the word congruent, which means they're the same degrees. Okay? First, that angle and that angle are the same. Okay? I also know that also means that this angle and this angle is equal to one another. Okay? I also know that alternate interior angles. So if I go across here, so for example, I can say that measure of angle 1 equals the measure of angle 6. I'm sorry, I wrote the wrong one. 5. 1 and 5 are equal. The measure of angle 2 equals the measure of angle 6. Now, if I cut through here, that's a straight line, that's 180. So whatever minus 180 gives me this number, so that's why those are equal to each other. That also means that this is a line also, so whatever minus this, 180 minus this angle, not only gives me 2, it also gives me 3. So the measure of angle 2 equals the measure of angle 3. Those alternate interior angles. That also means that 1 and 4 are equal to each other. Wow, so there's so many angles that start looking alike. So in reality, I'm going to have altogether measure of angle 1 equals the measure of angle 4 equals the measure of angle 5 equals the measure of angle 8. So 1 and 4 and 5 and 8 are alike. That means that 2 and 3 and 6 and 7 are all the same. The geometry of that makes it real easy. So if this is a line, then that's 180 degrees. 180 minus angle 1 would give me 3. That's also a straight line. 180 minus angle 1 gives me 2, so that means that 2 and 3 are the same. So if I cross over like this, those are equal. So that means 6 and 7 are also equal. Okay, and so 2 and 3 and 6 and 7 are also equal to each other. Okay? The other thing that makes life a little easier is that, I'm going to draw it again real quick. This angle and this angle equal 180 degrees, which means so do these. Those same side interior. Okay? Well, how can that be? Well, if we started with this one and this one are equal, and this one and this one are equal, this is a straight line. Well, if I know this one, then I know this one. So in reality, 180 degrees is what both of these have to add up to. That's also true here as well. So there are all these different angles, whether they be alternate interior angles, alternate exterior angles, corresponding angles, all of those things being equal to each other because of where they're located. So one more time, if they're in the same position, so there's a cross there and there's a cross street there, these two are equal to each other, those two are equal to each other, those two are equal to each other, and so are those. Since they're straight lines, 180 minus one of them gives you the opposites, so that using the geometry on that, these alternate angles are equal to each other, and inside they equal 180. What you're going to do in the next video is get to practice with some of those. You'll definitely do some of these, and you'll try some of these others with side angles. Let's see how you do.